Okay. So now let me repeat once again. So now today we are going to discuss about this streams. So now what is this? Stream is a kind of a one of the object in a Snowflake. So now how the stream is useful in a real time? So the stream is going to be capture the all changes or DML changes whatever we are doing in a base table. Base table in the sense the stream is will be always created in a top of in a particular table. So now if you take a real time use case example, so now take any domain. For example, if you take a health domain, healthcare domain. So now in a HDFC having a so many products, right? They have mutual funds, they have a healthcare products, they have a loan accounts. So now if you take HDFC health insurance, now if they want to know how many customers are purchasing this their daily their healthcare product. I mean to say health insurance policies. So now if they want to see how many customers are the what is the customers count of customers frequency on daily basis for that. So now I have a multiple tables are there. So now I am going to store this data into that particular table. So now I have a customer table. So I am going to store all these customers details into the customer table. So now my requirement is from this particular table, I want to find out the how many new customers are daily joining in this particular product. So which means joining to that health insurance policy means always there are new members will be added to the particular table. If there are like any modifications that happened, like if the some persons was like kind of a upgraded their policy, some persons are maybe deactivated their policy. So now with respect to these action item, if you take a customer table an example, so now like previously we have seen the customer details, right? So same example, take a same table as a here. Now keep aside about all these health product details and all. I'm just taking simply like a customer basic details. So now based on like how many customers are taking that policy means how many customers are going to insert into this particular table. Now then how many customers are upgraded their policy means how many customers are updated into this particular table. Now how many customers are moved out of from this policy or removed or deactivated that policy means you are deleting the number of employees from that customer table. So now based on these DML operations, if you want to do some analysis on daily basis how many people are coming on daily basis how many people are moving out. So now if you want to know some information about this particular use case for your business purpose, then that's where the streams coming to the picture in real time world. So now basically as I mentioned in a nutshell in very simple words, the stream is going to be capture all DML operations whatever you are performing in a base table. So the stream will be always created on a top of base table, top of some table. Of course you can create an views or you can create external tables and all, but in a real time we are going to create this stream on a top of table wherever you want to capture these DML changes based on your business use case. So just now I have given one real time use case, right? So based on that use case, if you want to capture all these changes, if you want to see how many customers newly added to that particular product, how you will be able to identify? See in table, like millions of records will be there. So now on daily basis, the task is running and the data is loading into the table. So now you cannot go and you cannot monitor every time in the logs and you cannot see like how many records are loaded and all, right? You know, just loaded, but how you will segregate it, like how many newly added customers are there, how many customers are modified. So there is no easy way to identify from the directly table. But if you create a stream on top of the table, then you will see all these kind of insights, that how we can create a stream and how we can track all these changes, how the stream is going to capture the changes, we will see practically. But is it clear about the stream concept, or like I mean to say what is stream and how the stream is useful for in a real time use case? Any doubt?
No.
Is it clear, right? So in a simple single point, the stream is going to be capture the all the DML changes, whatever we are doing or whatever we have done on the base table. So now we'll see quickly about these points, whatever I have mentioned here. So now the stream logically takes an initial snapshot of every row in the source table, which means is a base table. by initializing a point in time we called as a offset as the current transaction version of the object. What it is means, now I have a customer table. Okay, so now I have inserted 10 records into the customer table. So now when I have inserted these 10 records, immediately these 10 records details will be populated into the stream by saying these all records got inserted. Okay, so now this is one transaction. So now you will be doing a multiple transaction during a one time frame in the sense. So now still you didn't query the stream. So the stream is exist, but you didn't query the stream. So until you query the stream will always having the data. Once you query the stream, automatically the stream will be wiped off, which means the stream will become empty. So now before querying the stream, whatever the transactions you are doing, that will consider as a one offset, which means one transaction. So now I have inserted 10 records, then I have updated 2 records, then I have deleted 5 records. So now all these 3 transactions details will be populated into the stream as a single snapshot, which means point in time. So until you consume the data from the stream, it will be captured all the transactions together. So what is mean by that? That we'll see in a practically. But what is mean by offset means as a point in time from where you loaded the data into the table and where you consume the data from the stream. For example, within 2 minutes, you have performed all DML operations. After 2 minutes, if you query the stream, that entire period we called as a offset. Now, the change tracking system utilized by the stream then the records information about the DML changes after the snapshot was taken. This is what like. So we have discussed about CDC process, right, in data warehouse. Change data capture. So if you want to do this change data capture in a Snowflake, you are going to use these streams. Change data capture means like whatever the changes was happening at source end, we are going to capture the changes and we are going to bring the changes into the target, right? This is what we have discussed. So in Snowflake also, like whatever the changes was implementing at source end, you need to capture that, right? So now always we are getting the new set of data and we are just placing the data into the staging table. Then you need to see what are the changes is happening. You want to capture the changes. It is making our life is more easy. So in Snowflake, if somebody is asking how you can implement the CDC process by using a streams, we can achieve that. The change information mirrors the column structure of the tracker source object and includes additional metadata columns and describe that each change event. So what it means, now for example, table having some 5 columns. Now, apart from these 5 columns, when you create a stream on that, so these 5 columns also populated into the stream, and apart from this, the stream additionally bringing some 3 additional metadata columns. So what is mean by that metadata columns and how the stream is looks like, we'll see in a next slide. Now note that stream itself doesn't contain any table data, which means stream it doesn't contain any data, it just depend on the table. So whatever the data is present in the table, the same data will be mirrored into the stream with additional metadata columns. So now before going to the 3 types, let me show you kind of how the stream is looks like. So what I have mentioned here. So now for example, I have a table. This is the table. I have created a stream on this particular table. So now if you see the column 1 and column 2 will be there. And if you see the stream, it looks like, as I mentioned, whatever the data is available in the table, it will be mirrored into the stream. And apart from that, few additional metadata columns will be populated. Stream itself doesn't hold any data. Okay, so what is this metadata and all we will discuss in a couple of minutes. So is it clear about streams overview? What is mean by stream and what the stream will basically do? Any
Yes, sir.
doubts with respect to that? Clear, right? Okay, so now the stream types. So now basically the Snowflake will support 3 types of streams category. So whenever you are creating a stream, by default it will use as a standard stream. So this is the mostly widely used stream type. If you are creating a stream on base table, automatically it will considered as a standard. So this you can create a table, view, dictionary tables, wherever you want, you can create this standard type. So now this particular standard stream is going to be track all DML changes on the source object, including inserts, updates, and deletes. So basically, what is difference between these three types of streams? One is standard, other one is append only, third one is insert only. So standard means it is going to be capture all types of DML changes. Append only means it will support only for inserts alone, which means it is not going to be it is not going to be captured by any delete or any updates. It will just capture only inserts alone. Now coming to insert only. So this third type is a kind of, it is only recommended for external tables. This also is going to be capture only insert only. But this append only in insert only, we will use a rare frequency. Third one is completely kind of a very rare scenario. People will touch that. We won't touch that in normal cases. Now coming to the first two types, standard one is the most widely used one. Append only, for example, if you are dealing with the delta changes and all, that's where you'll use this append only, which means like whenever you are getting a new data, it will append those new set of records into the target table, right? So in such kind of scenarios, we will use this append only stream. But now we'll see demo for first type only because that is the widely used one. So these are the three types supported by Snowflake. The basic high level difference, basic or a high level difference between these three, if somebody is like looking, so standard means it's going to capture all types of DML changes. Append only means it is going to capture only insert statements. Insert only also, it is going to capture only inserts only, but it is only recommended for external table. You cannot use for other tables, the third one. So these are the stream types. So now if you see the kind of a workflow of these streams, so now these are the source, I have a data. So now at source end, whatever the changes are happening, so the changes they'll pick up and they will send every day to kind of our Snowflake environment. So now we know kind of there will be some staging area or landing area will be there. So that is something as a external stage. In our real-time projects, mostly we are going to use these are the three cloud platform, either AWS, Azure, Google Bucket. So now first we are bringing the data into this particular staging area or landing zone in the form of feed file. In the form of feed file in the sense, in the form of either CSV file or a JSON file or a Parquet file in the form of basically file, not in a table. So now once you place that file into this particular external staging area and you are going to create a stage reference into that Snowflake environment and you are going to execute the copy command and you are going to load the data into that particular staging area. So once this is not a staging area, this is a stage layer and this is a staging area or landing zone. So don't confuse between staging area and stage layer. So staging area is kind of a temporary storage space. It is outside of the Snowflake. When we are talking about the staging layer inside the Snowflake, it is a kind of a database inside the Snowflake. It is a kind of a either stage database or raw database or curated database. So it depends on organization. They will use a different naming conventions. So now here we are using a kind of a stage layer. So in this stage layer, I have created a file format. I have created external stage and I have loaded the data into the staging table. So now once I loaded the data into this particular stage table, so before moving to that further layers, if I want to capture the changes, so what I need to do, I am going to create a stream on this particular table. So now once I created the stream, so now the stream nature is by default, it is going to be capture the all the DML changes, whatever is happening on that particular table. So now before loading the data into that integration table, so first I need to load the data into the stage table. Now just example, I have taken a kind of a delta load. So now or any kind of a load. So now first initial load, I have received 10 records and I have loaded the 10 records into this particular stage table. So now if you go to the stream, then the stream will capture all these 10 records. It is saying as a insert, and the stream having these 10 records. So on top of the stream, I can build a some merge procedure or merge command. So now I'm going to load the data into that int table. I'm going to load the data into int table. Or else, if you don't want to create a stage in a particular stage table, you can create a stream in a integration layer. So before going to presentation layer, you want to know the total, how many inserts are there, you want to know how many deletes are there, you want to know how many updates are there for use, for suppose kind of a one of the use case. So now take an example of initially whatever I have discussed, right? So I want to see how many new customers are adding to that particular product. So now if that is my case, first I'm going to bring the data into the stage table every day, because I'm going to receive a full load every day. I'm receiving a truncate and load here in the stage table. So now first day I have received 10 records. I have loaded the 10 records, and I have ran merge statement between the staging and integration. So first time all these 10 records into loaded into that particular int table. So now the stream also going to capture the 10 records. Okay, that is the first transaction or first load is done. Now the second load from the source end, out of these 10 employees, the 10 customers, maybe two customers are moved out of the from product and two customers are upgraded, and newly two more customers added. So as part of next day, I'm going to send another 10 records. I'm going to send another 10 records. So now coming to the stage, I'm just truncating that existing 10 records. I'm loading the new 10 records. So now I need to compare with that yesterday's 10 records from the integration and today's 10 records from the stage, and I'm going to merge the data into that integration layer. So now as part of the second load, what is happening here? So out of these 10 records, that two records are deleted and two records are newly inserted, or remaining maybe updated. So now deleted ones, anyways, it won't present in this particular staging area as well. And we are getting the remaining updated, upgraded or new ones, whatever the 10 records are there, I'll just match with that integration layer and I'll compare it. So now whatever is matching, if the values are modified, it will just merge operation, basically it will do update and it will do insert. So if the existing records are matching, automatically update those records, and if new records are there, it will automatically insert into this int table. So now first time 10 records got inserted, the next time 10 records, it is a kind of out of 10, maybe 2 or 4 as a new records, the remaining 5 or 6 is a kind of a old records might be updated. So now when I ran that merge statement in that int table, now out of these 10 records, maybe 5 got updated and another 5 records got inserted. So now yesterday in the stream, I have 10 records. So now if I consume the stream, by the time will be empty, and now I am going to insert into this particular new set of records, maybe updated records 5 and newly inserted records are 5. If in case I didn't consume the data into the presentation layer from the stream, it is simply what it will do. It will just update the same 5 records, existing records, and newly insert into the another 5 records. So from that particular stream, I can see how many new records got inserted, how many records got updated. So this is how this entire flow will work in streams. So you are just referring the stream for how many new records are inserted, how many new records or how many records got updated, because the stream is going to be give a detailed information about that each and every record. So as I mentioned, like it it will populate another 3 additional columns as a metadata columns in the stream. So those columns is going to give a overview for you, like how many records got inserted or how many records got updated or how many records got deleted. So now for example, if you see here, so this is a table 1. So now newly inserted the data into this table. So I have created on top of this table as a stream. So now when I insert the data into this particular table, the stream is automatically going to capture that change. So it is a kind of a DML, right? So now how the stream it looks like. So the same data will present here also, whatever the data is present in base table, and additionally it is going to be populate 3 metadata columns. One is metadata action, metadata is update, metadata row ID. So this metadata action is basically it will specify what type of DML operation. Is it a insert or is it a update or is it a delete? Then this metadata is update. If in case that record is newly inserted, it will show as a false because this is not a modified record or this is not a updated record. This is a newly insert record. So this is update always having a boolean values either true or false. If it is a updated record, it will show as a true. If it is a insert record, it will always show as a false. And the third metadata is row ID. So this is a kind of it will generate automatically by Snowflake. It is a unique ID for that particular record. If you want to identify unique record from that provided, since you are getting a multiple records, right? Like multiple DML operations you are performing, right? If you want to see like a unique identification for each record, so this is how you can find out the unique row from that particular stream. So these are the key metadata columns will be by default populated by the stream and significance of each column. Number one is a metadata action. This particular column will specify is it a insert or it is update or it is a delete. The second metadata column is update. If it is a insert, it will show always as a false. If it is update, it will show as a true. The third one is it will show as a row ID for each record. Now this first case is I have inserted. Now coming to the second case, so I have inserted two more fruits and I have updated existing one. I have updated existing one. Now if you see how the stream will going to capture the changes. So initially people one it is got inserted, right? Now orange banana new inserts, orange banana new inserts. So it is metadata action item is showing as insert and this is update as a false and this is a unique ID. Now coming to that update, so this is another important point you need to remember in streams. Whenever you are updating something in a base table, the stream is going to treat that as a two of operations, which means behind the scenes what it will do, it will delete that existing one and it will insert the new one. So for each update, Snowflake stream is going to capture two entries. One is for delete, another one is for insert. So one update in a streams, it is a kind of a insert plus delete plus insert. So now earlier Apple 5 I have inserted. Now you are updating it to 9. Number of items you are updating from 5 to 9. So what the Snowflake will treat, how the Snowflake will treat behind the scenes in the streams. So it will remove that existing one 5 1 and it will insert the new one. It will insert the new one. But the newly inserted one also, how you can identify like it is a modified one or not. It will show is update as a true. So from this particular stream, if you want to find out only inserts, is metadata action equal to insert. Select star from the stream where metadata action equal to insert, which means you will be able to find out the all inserts. If you want to find out updates, select star from the stream where metadata action equal to insert and metadata is update equal to true. Then you will be able to find out the all updated columns. And deleted ones, it is pretty much straightforward. So metadata action equal to delete and metadata is update is false. If you delete something from the base table, automatically that also will capture as a delete. It won't any difference here. The only difference is for update. Whenever you are updating something, the Snowflake table, that update will consider as a two operations. One is delete the existing one, insert the new one. This is how the stream will capture the changes, and these are the metadata columns. And during interviews, people definitely will ask like, so how the stream is differentiate with the base table. So in base table, whatever the columns are there, the same columns will be present in the stream as well. And additionally, three metadata columns will be populated. So people will question like, what are the metadata columns and what is the significance of those columns? So three types. One is the action, metadata action. Metadata is update, metadata row ID. So metadata action is specify, it is a kind of a what type of DML operation. And is update, it is a Boolean attribute. It will specify is that particular record are inserted or updated. And the third one is unique identifier for the each row. So this is how you can capture the CDC changes from source system to target table by using these streams. This is how the stream workflow will run. So is it clear or any confusion here so far about the streams? So what is mean by stream? What are the metadata columns are there? What types of streams are there? How the streams data is going to be dealt with? We'll see practical demo, but is it clear about that flow process of overview?
So metadata available.
Metadata, sorry.
So metadata concept is not understand.
So these three columns by default stream is going to be populated. So when you create a stream on this particular table, yep. See now this is a table. We know how to create the table. Now whenever you are inserting the data into this table, on top of this table, I have created a stream. So when I create a stream, I'm not going to give all these column names and all, nothing. I'll just create or replace stream name on top of this particular base table. So once I create the stream, whenever I'm going to insert the data into this particular table, the stream is going to capture all the changes automatically. You don't need to do anything. You just create the stream on this particular table. So when you create a stream, the stream will just replicate or mirror the base table data. Along with that base table data, additionally, it will populate three columns. Is action, is update, and row ID. So what is the use of these three columns? You want to identify, right? Like see, now we are saying that stream is going to capture all the DML changes. How it is going to capture the DML changes? How you can identify what type of DML operation is performed on that particular table? So in order to help for that particular functionality, the stream is giving these three columns and it is specifying explicitly this is a insert and this is update and this is a delete. So based on these metadata columns, you will be able to identify what type of DML operations performed on that particular base table. So we'll see the practical demo, then you will get more clarity on that. Okay.
Yes.
Any other queries? Okay. So now we were discussing about offset, right? Something called as a offset. So I have mentioned is a offset is a kind of a time period between two transactional points. For example, I have a stream A and I'm doing multiple DML operations on that particular table. So just assume employee table I have. So in employee table, I'm doing a insert, delete, something like that. These all we call for each DML operation we call as a one version. Each DML we called as a one version. So now at 10:30 I have deleted, then 11:30 I have inserted again, 1 o'clock I have inserted, then 2 o'clock updated, 4 o'clock deleted, 5 o'clock inserted, then 6 updated. So now if you see from here to this period, these are the CDC change data capture records, right? If I want to capture all these changes between this particular time frame to this particular time frame, we basically the offset means from here to here between two transactional points based on certain time frame. If you want to capture the changes, so with help of the streams you are going to capture that changes and you are going to do analysis on particular data. So don't confuse with this. It is a pretty much straightforward. As I mentioned, until you consume that particular stream, it is going to be considered as a one offset. So now I have performed multiple DML operations. All the DML operations will be captured by as a single snapshot and one offset in stream standpoint. So this is might be little bit confusing, but don't worry. While showing the demo, you'll get more clarity. If she's still not clear, I'll repeat once again. So now like as I mentioned, the streams and tasks is a kind of a good combo. Whenever people are talking about how we are going to implement SCD type or SCD types in a Snowflake, how we are going to process the CDC records in a Snowflake, immediately should come into our mind. It is possible in Snowflake by using streams and tasks. So how this kind of a workflow it looks like. So now if you are doing an insert or update deletes on a particular Snowflake table and you have already created a stream on top of that particular table, then you are going to schedule a task and you are going to run the SQL logic or store procedure. So as part of this SQL logic, you are going to identify how many inserts are there, how many updates are there, how many deletes are there. So like if you want to implement SCD type, so you want to know, right, like what are the changes has happened. Then only you can implement the SCD type. So by using this two combo, we can achieve that CDC process. So now what key points needs to remember as part of the stream. So basically the stream is going to be capture all the DML operations performed on that particular table at a point in time. And the second one is consumed in DML statement designated for transform T from ETL. So what is ETL? Extraction, transform, load. So now streams will point to that transform. So this is where coming to the picture, right? SCD type 1, type 2, type 3 and all. So whenever you want to implement such kind of functionality in Snowflake, you will going to use this particular streams and tasks concept. So multiple streams can be possible to create on a particular table, and stream table does not hold any data. Please remember this point. So stream doesn't hold any data. Hold in the sense it won't store any data for itself. So it's always depend on the source table, and on source table whatever the DML operations we are performing, so those DML operation changes will be reflected into the stream. Now the stream cannot track changes in materialized views, which means streams cannot created on materialized views. This is one of the Snowpro certification question. So they'll ask like, okay, can I create a stream on a materialized view? True or false, or like true or false, both or none. So we need to select right answer for that. And change retention determined 14 days or max data extension time in days. So what is mean by this change retention? So we had a kind of a overview about the time travel, right? Still we need to discuss about that, but kind of a, so always when we are talking about the time traveling means data retention period. So retention period means like how many days you want to keep the data. So similarly, if like the stream, if you are not consuming the stream for 2 weeks, automatically the stream will become inactive, or automatically the stream will become stale. So if you want to increase that, you need to set up particular number, but that also it maximum it will allow up to 90 days. So like up to 90 days, if you want to keep it, we can keep it, but ideally in real time projects we won't keep it that many days. We'll keep it only 14 days or 7 days. So now if you keep it 14 days, then if you consume the data within the time frame, you will be able to read the data. But if you want to consume the data beyond that period, then it will show as a stream kind of a became stale, in the sense it is became a inactive. This became a inactive. So now if you see, for example, like if you set up the data retention time in days as a 14 days, and you will be able to consume the stream up to 14 days. If you set up 1 day, and if you set up this max data extension time in days, this is the key parameter for the streams. So whatever you are able to set up here, based on that many days you will be able to consume the stream. So what is mean by consume stream? So you are just pulling the data from the stream and you are going to insert the data into the table. That is we called as a consumption of the stream. So that we will see now. When we execute that query, you will get more clarity. Might be in our mind, couple of follow-up questions are like little bit confusing, but don't panic with that. So once you see that this practical queries execution or practical demo, you will get more clarity on that. On post that, still if you have any confusion, just let me know. I will clarify that. So let's quickly jump into the demo. Then we will clarify all our doubts there itself. See now, I'm just creating a three kind of a tables. So whatever use case, real-time use case we have discussed, right, starting. So I'm going to implement the same use case. So now my requirement is I want to see how many new customers are daily adding to the customer, which means automatically those many customers are purchasing that particular product. So now I'm keeping aside about the all the health or policy information. I'm just taking as a reference of the same customer table. So I want to see how many records are inserting into that particular table. Then I can assume, okay, same number of customers are purchasing that product or upgrading that product or deactivating from that product. So now for that, I'm creating a three tables here. So one is stage table. So the first data will be coming to the stage table. Then I'm going to merge the data into the INT table. On top of this INT table, I'm going to create a stream. On based on the stream, I'm going to fetch only inserts or only deletes or only updates whatever I want, and I'm going to populate the final result into the presentation table. So for that purpose, I have created a three tables: stage table, INT table, and PRS table. So now first I need to bring the data into the stage table. So this is the same process. Like I'm going to create a file format. This is we have done right last time. I'm going to create a stage. I'm going to create a stage and I'm going to place the file into this particular stage. Then I'll run the copy command and I'll load the data into the my staging table. So now this is my named internal stage. I'm going to place the file. So all my data files will be available in this particular location. I have placed customers three set of data for variation. So now I'm going to place one of the file from this particular path to my Snowflake staging area by using a snow SQL command. So I'm going to snow SQL and I'm just executing this particular path. I can see the customer data is loaded into this particular stage. Now if you see this particular stage, you will be able to see the customer data is present. So now what I'm doing, I'm going to load the data into that my stage table. This is the first step. I'm just running the copy command. So now if you see the stage table, these are the records are available. There are 9 records are available. And if you see INT table, you won't be able to see anything. If you see PRS also, you won't be able to anything.